Alright, this is AP Stat. I'm still in Unit 1, but this is Chapter 6, just going over some practice problems, and we've been going over what affects the mean, what affects the median, and all the different variations like standard deviation, things like that, how it affects when you multiply something or add something to it. Then we started going over the empirical rule, looking at the normal distribution to see how this stuff all plays out, and we're still on that. So again, if you need to pause these to write down the problems, please feel free to do so. But otherwise, I got to move fast, try to get through as much of these practice problems as I possibly can, and you guys can see the answers as well. But this basically is saying that we're using the cattle problem from before, which was a prior video when we were using these examples, and it said it's a normal model. You have your mean of 1152 and your standard deviation of 84, and the normal model for weights of Angus steers. It says what percent of the steers weigh over 1250, under 100 pounds, and between 100 and 1100. So you can plug this all in your calculator without changing it to z-scores. But the point I'm getting at here is I want to alter things into z-scores so we can get some practice, okay, and then use the calculator for it. But the point is, if I start going up by 84 and then up by 84, it doesn't land exactly on a standard deviation. So the empirical rule, as helpful as it is, won't be very helpful. So the point is, when working through this, they want to know 1250. So what they did was, if I know the mean is 1150 and the standard deviation is 84, right? What we basically have here is the 1250. I plug it all in and I find a z-score. Well, because I drew my picture, because they always want us to draw a picture, and I have my 1250 and I want to know everything over that, I basically want to know what this is. So what we do is we can go to our calculators, and if you press second vars, you'll see something that says normal CDF, right? And you press that. And the starting z-score we got was 1.167 when we plugged it in here, right? And when we did that, we want that to go from 1.167, then put a comma, and then put a 10, because it's, so you could put a 10, you could put 100. You want a number way out here, z-score wise. And think about z-scores. A z-score normally goes like, within three within 3 standard deviations of either side, you're getting in between 99.7% of the data, right? So by using a number like 10, that would be like way out here and practically impossible, which is why you can put the 10 in there. And then the mean, because we're in terms of z-scores now, is 0, and then the standard deviation is 1. And when you put 0, 1 and press enter, you end up getting approximately 12.16 or 12.2%, so you don't even need to use a table for it. However, just so you can see how this works otherwise, you could just go with second vars and click the normal CDF. And because I want to know from 1250 up, I could just do 1250 without doing the z-score up to, and then you can pick an exorbitant number again that's way out here. And we're talking about pounds, right? So if you did something absurd like, let's go with 100,000 pounds, right? If I did something like that, you're not going to have a steer that's that absurd, so you could put it way out there, because technically this goes to infinity, but I'm not writing it. But then comma after that, and since the mean is 1152, and then comma, the standard deviation is 84, and then you close those parentheses and press enter, and you will still get the exact same answer without even doing the z-score. Okay, so according to this normal model that we're using, 12.2% of the steers are expected to be above 1,250 pounds, basically. But now it wants us to do under 1,200. Well, if I do under 1,200 to get some practice to do z-scores, right? 1,200 goes in here. I know the mean. I know the standard deviation. So I can plug those in, and I end up getting approximately what my z-score is. But they want it under. So the picture helps with a rough sketch so you can see, oh, I want everything this way. So when I go and plug this in, I will press second vars, so I could get my normal CDF, press enter. And then after I have my normal CDF up there, this down here, because it's in terms of z-scores, remember how I said up here it was like 10 z-score? Well, you could go with like a negative 10 way down here. So type in negative 10, comma, because you always go from low to high when you're using normal CDF. Always low to high. Well, the low is negative 10, The high here is 0.571, comma. Your mean in terms of a z-score then is 0 because we're using the normal model, and your standard deviation is 1, and when you press enter, you end up getting approximately 71.6%, which is what they got. And again, you could go with second vars and go down to normal CDF. And here, again, I used about 100,000. You could use like negative 100,000 pounds up to 1,200 pounds. And then afterwards, comma, right here you put the mean of 1152, comma, and the standard deviation is 84. And when you press enter, you'll still get the 71.6. Either way you slice it. So either way, you're going to get that, according to the normal model, 71.6% of the steers are expected to weigh 1,200 pounds or under. And then I went between 1,000 and 1,100 pounds, so I need to find the z-score of each. So I plugged in 1,000, 1,100. There's my mean that was given. There's my standard deviation that was given. There are my z-scores. So I draw a picture so I can see again where everything is at. There would be the 1,000, there would be the 1,100, so I went between there and there. But once you rewrite it in terms of z-scores, you press second vars. I would scroll down, and I want it between negative 1.810 as my low, comma, negative 0.619 as my high, but then our mean is 0, and our standard deviation is 1 with the normal model, and I get approximately 23.3. They are correct. And again, you could do second vars, go down to normal CDF, and now your low is 1,000, your high is 1,100, your mean is 1152, and your standard deviation is 84, and they can do it without switching into z-scores and get 23.3% as well. Right? So, according to the normal model, 23.3% of steers are expected to weigh between 1,000 and 1,100 pounds. Okay, this is the idea going through. I try to do that one a little slower so you can see what we are typing in. So now I am just going to spit out what we're doing and how we're doing it so we can get this. Normal model, 100 is the mean, 16 is the 16 is the standard deviation. If I want over 80, this is why we draw the picture, right? So there's 80, there's 100, anything over that. So when I type this into the normal CDF, I could do normal CDF 80, right, as the low, comma, 1,000 as the high, because that would be an exorbitant number for an IQ, comma, and then the mean of 100, the standard deviation is 16, and it would give me my answer of 89.4%. Or I could do my normal CDF, and I could do negative 1.25 after I make it into a z-score over here, up to like 10, comma, 0 for your mean when you're doing the normal model, and 1 for your standard deviation to get your answer of also 89.4. So according to the normal model, 89.4% of your IQ scores are expected to be over 80. Under 90, again, you draw the picture like we're used to, and it's just a rough sketch. This isn't anything fancy, right? I know the mean. That makes 90 here. I want anything under that so I can visualize it. So I could do normal CDF. I could do maybe negative 1,000, because there isn't no infinity, but like negative 1,000 up to 90, comma, the mean's 100, comma, standard deviation, and I'll get 26.6%. Or I could take that 90 and I could plug it in and make my z-score. So now it goes from like negative 10 to negative 0.625, and then mean of 0, standard deviation of 1. Either way, I'll get 26.6%. And according to the normal model, 26.6% of the IQ scores are expected to be under 90. And then last but not least, between, all right, again, I could just do normal CDF between 112 and 32. So 112, comma, 132, comma, mean is 100, comma, standard deviation 16, and I will get 20.4%. Or you can switch them to your standard deviation and now go from normal CDF 0.75, comma, 2, comma, mean is 0 when you're talking about the normal model, standard deviation is 1. and plug it in, and you will also still get 20.4. So according to the normal model, 24.4% of the IQ scores are between 112 and 132. All right, based on this as well, all right, what are the cutoff values for the highest 10% of the weights, the lowest 20%, the middle 40%? This is us working backwards now, okay, doing the same thing. So if I want the highest 10%, this is why you draw the graph. Highest 10%, I know that's the mean, right? Highest 10% is right here at labeled as 10%. And the problem is we're trying to work backwards in order to figure this out. Now, we can in turn use the calculator to help us solve these problems and get the answers. And that's why I'm actually going to stop the video here, because I don't want to cut us off halfway in a problem. So when we come back, we're going to see how to use the calculator in reverse to get these answers.